thank you for joining this session. I'm Luca Relandini from Cisco. I'm a technical solution architect in a European team that works on data center automation and cloud. I'm speaking English because the session is recorded and will be published. So thank you for joining this session. It's very important because I'm going to tell you a secret. Cisco, probably known as an infrastructure company, actually makes software. And this software is even open source. So the project Contiv that I will explain today is an open source solution for networking that works with all the platforms that manage containers. So it integrates into Docker, Kubernetes, and the others. It's been recently published in the Docker store. It's actually the first network solution published by Docker on the store. So the introduction will be very short because I know that you already know these concepts. You have already worked probably or played with them. Containers are a very useful deployment unit because they package the application code and all the dependencies, and they are supposed to work very well in all the places where you deploy them. So in a bare metal server running directly on the machine, in virtual machines, in the cloud, they bring whatever they need to run the application consistently. Microservices are a pattern in designing applications. So they are building blocks that creates the application altogether. They have relationships, and of course, they can be used to access data in databases or to implement the business logics. So this graph could be an e-commerce application. Of course, microservices take advantage of containers as a very smart deployment form. So this is changing the way operations are done in the IT world, because different from the past, from traditional IT, now people that develop applications and people that operate them in production try to collaborate, at least have tools to collaborate. Then it is the human factor that is the most important criteria for the success of an organization. So once the updates to an application due to bug correction or enhancement in the business logic took a long period, the life cycle of a project was very extended. Now you can have deployments every day in production or maybe every hour because of the evolution of technologies and the way of doing things. So the applications are no longer a monolithic block of code, but is a kind of puzzle of microservices that interact to each other. And of course, that helps the agility of the project and help the collaboration across those people. So you see different roles that communicate, and they have integrated platforms and tools to work together. So that seems to be much easier than it was before, but the adoption of containers is not immediate. Everybody talks about that, but in real production environment, we still see not so many containerized applications or based on microservices. If you interview the responsible, that means the leaders of the operations team or the CIO or the CTO, they have some concerns. Most of them are based on security and networking because the architecture is complex. There are many technologies in the play, many products, many tools, different skills required. So to be sure that everything works, there are no troubles. Troubles means damages to the brand or money problems. So they are trying to be very prudent and to stay on the safe side. Also because technologies and tools available today are not so mature yet. So everybody is looking for a production-grade infrastructure. And Contiv is an attempt to give an answer to this request. So networking is increasingly complex because when the applications were deployed directly on a server, on the operating system, you had to configure all the networking aspects in the machine and in the network with virtual machines, you have an additional layer, so the virtual networking on top of the physical networking. And when you run containers, generally you run them inside virtual machines, so you have one more layer. So the interaction and the management in a consistent way of all these layers is difficult. So there are some problems that should be addressed, like using services in the network, load balancers, firewalls, how to attach them to the containers running in a virtual machine, running in a host. Performances, because every layer have a kind of encapsulation of the traffic, and of course, one encapsulation inside the others can affect the performance more or less depending on configurations and technologies. And also, it's difficult to leverage the value of the hardware that sometimes have specialized components to do operations very fast and very reliably, like SSL encryption and so on. So if you cannot leverage that because you don't control, you don't integrate directly, it's even more difficult. So there are architectures made on purpose to help these problems. And the major platforms that offer container support, like Docker, Kubernetes, and the others, have created architectural models so that eventually you can plug in an external solution to improve the way networking works. So the basic is that inside the host, you have the operating system doing the networking and offering some services to the containers. The most important services, the basic ones, are, of course, IP connectivity, the management of IP addresses, so having a pool of IP addresses and subnets to be used for containers, and, of course, the network address translation or any other kind of communication with the external world. So the two main models for managing the networking are CNM, invented by Docker, and CNI that we will see in the next slide. So essentially, every container has a sandbox that encapsulates the networking aspects. There is a namespace. There is the possibility to create some Ethernet interfaces that are actually coupled with other virtual Ethernet interfaces running in the host, in the bridge host, in the virtual bridge running in the host. So a network is essentially a set of endpoints that can communicate. Some solution does that very well on a single host. You start having troubles if you have a cluster of different hosts in the same data center or in separate data centers. So managing containers networking at scale is difficult. So CNM provides the API specification for every vendor or single developer that wants to build a network plugin for Docker, Swarm, and the other projects that use this kind of architecture. CNI has been invented by CoreOS and has been adopted by Kubernetes. It's an alternative architecture for networking. So it's a different specification for the API. It's probably simpler. At least it has fewer API. So the difference is that the driver has more power than in the other one in making some decision. And the platform that generates container passes information to the driver to create the plumbing, that is the connection between the container and the rest of the world. And there are just two API. So Project Contiv embodies both the interfaces. It can work in all the containers platform in the market, and it is a kind of universal solution for bringing the enterprise-grade qualities of the network into the container world. So why Cisco started this project? As we said, there are different players in the IT lifecycle. They have different needs because, of course, they have an objective. They just care of what they see on their table. So developers and testers on the left side want to be very fast, want to be agile, so have all the resources immediately available when they are creating something new or they want to test it So they want to generate a test environment in minutes or seconds, maybe, run their tests, eventually remove everything, create one more, move the application to production without losing that much time in meetings, email exchange with the system engineers to have the environment created. And of course, they generally work on unit testing, so they don't care the integration with other people's work or the ecosystem where the application will run, so the interaction with all the other systems that run in production is not their problem. The administrator, on opposite, is not interested in a specific application or specific unit of the application that could be a microservice. So they don't care the pets that are so loved by the applications. They care the entire extent of the system. So they want everything to be stable and secure. They don't want to have risks. They don't want to have troubles or performance issues. So application must run according to specific rules, should be isolated, should be compliant with some rules. So how to help those guys to work together and provide a good result to the company? The solution seems to be managing the system based on policies. Policies are actually tags, so a declarative way of asking some behavior to the system. You don't need to understand and to know the syntax of complex commands. You don't need to understand the technology that is behind. The administrator have created predefined rules, associated maybe a name with them, and give you the name of the rules or the policies that are available to you as the designer of the application. So the administrator also decides who is enabled to use the specific policies. So a role-based access control is one of the most important things to avoid that everything has complete freedom and does things that are not allowed. So using tags is simpler and is also accessible to application developers that have no knowledge of the underlying technology. And the other aspect is that through policies, you can manage very large groups of objects in a consistent way. So you can apply a configuration not to a container, not to a microservice, but eventually to 10,000 microservices running in the same group. So if you want to change which ports are open on the network, instead of doing that container by container, you apply that rule to an entire group, and all the containers that have been associated to that one, manually or by Kubernetes or by Docker Swarm or whatever, will inherit the change and the new policy. So Contiv helps doing that. It is an infrastructure solution based on policy, which is scalable across many hosts and different data centers, also in a hybrid cloud environment. So it tries to bring together the application intent, that means what the application developer wants to build and to achieve as a result of the application, and the operational intent, which is the objective and the way of working of the administrator. So both the players are made happy by using this. So initially, Contiv focuses on networking in a distributed architecture, but we also have plugins for storage that will be released later. So now networking is the most important and the immediate problem to solve. And it is open source. So Cisco is not making money from this. It is just pushing that to the community to try to help and to demonstrate that we are a new company compared to what most of the people are used to know since 25 or 30 years ago. So what is the representation of this application intent and the operational intent? On the left side, you see an excerpt from what could be a compose file, as an example, describing the application, the different components, the tiers that are there. So what the application developer understands and wants to deal with. on the right side, you see other parameters, other information that are not relevant for the person that is creating the business logic, but are important for the administrator that must run it in production in a safe, consistent, scalable, and performant way. So it will, now we represented that in this way just to use the same format and make the difference in the parameter semantics appear. There will be different ways of configuring that because we have a user interface, we have a CLI, we have REST API. So all this information can be passed to Contiv in different forms. This is the architecture. So we have user interfaces. That could be a web user interface or, as I said, command line interface or REST API that are used by the different players. The integration with application schedulers. So you see some here, but we also support OpenShift as an example. So we have Swarm, Mesos, Nomad, Kubernetes. And of course, the enforcement of the policies is distributed across a huge number of hosts. So it's not just working on your computer, but it's working in the production environment in the data center. And it is working in the same way. So if you test it on the Mac and you bring it to the system administrator to put it in production, it will work exactly the same. So Contiv can run on any physical infrastructure. Of course, if it is a Cisco infrastructure, it's much better. We are happier. On any computing platform, any networking. And of course, it tries to make the DevOps team and the IT administrator work together and be happy because we give them the solution for making their work faster and easier. Okay. So those are the most important features that you will see in the next of the presentation. So integration with different platforms, compliance, security, integration with the hardware platforms, and so on. So here I represented two Cisco products. You might be aware of the application-centric infrastructure. It is Cisco's SDN solution. So we have a software controller that manages all the fabric, that is number of switches working together. Instead of managing every machine one by one, you just talk to the API exposed by the controller and you have the behavior of the networking in the physical and the virtual world managed together. So Contiv eventually talks to Epic, which is the controller for the ACI platform, or talks to any other physical switches from Cisco or from other vendors to delegate the work that those guys can do very well. So instead of implementing that in the software layer in Contiv, we push those requests to the hardware. So Contiv exists since 1 year, probably, but recently in February, it has been released in version 1.0. That means production ready. So it was an experimental project. Now it is robust and performant enough to be used in production environment. In fact, I said that Docker exposed that in Docker Store as the first solution for networking. So those are the highlights of the solution. So it is open source and free, but very shortly we will announce also a supported version, a la Red Hat. So you can use the product for free, or you can have technical support paid and granted by the vendor. So we want to address these needs. That means an infrastructure that is ready for enterprise-grade application. And as I said, it offers tools, different interfaces, role-based access control. It is distributed in Azure, so works very well with large clusters of hosts running the container. It is stateless. That means if the system fails, you can restart it immediately and safely. And manage global resource pools. So it integrates very well with large ecosystem. It talks to all the managers for scalable resources. And this is how the product the project is built. It is made of two parts. The master, which is an instance that, of course, will be multi-instantiated for high availability and performance, so it can scale to very large environment. And it has an agent that runs on all the hosts in your cluster. So within the host, you have, of course, a layer that talks to the external network, and you have internal components that do the feature that we have discussed already. And then, of course, there is a bidirectional integration with the container runtime. So we have the implementation of IP address management, the health state of the system, the database for the entire configuration of the system, and a distributed key-value store that helps all the nodes to work together in an efficient way. Now, it's time for a short demo. We demonstrated that at Cisco Live in February in Berlin, which is a huge event from Cisco to showcase the new technologies. I wanted to reuse the same demonstration here, but yesterday I decided that you will do that yourself because it's more exciting. So actually, the installer, the source code, and the tutorials are available on GitHub at this address. I have run the demonstration in my computer. I've taken a lot of screenshots, so now I will show you the screenshots. But I very warmly invite you to download the tutorial because it's very easy. It is a couple of virtual machines running in Vagrant, so you can run them on your computer. And Contiv and Docker are pre-installed in the virtual machine. Of course, you can also start from a blank environment, install Docker yourself, install Contiv. But if you start with the tutorial, it's very, very easy. And we offer different tutorials on container networking, on application of policies, and eventually the integration with ACI. So now we will see something together, but please go there, download it, and play because you will be excited by the easiness and the results of the tutorial. So in general, in Docker, you have different ways of creating networks, different implementations based on the native drivers offered by Docker. And then, of course, you create containers manually or through the integration with Kubernetes and the others, and you attach them to the networks. So if you inspect the local bridge, the Linux bridge in the machine, you will see, of course, the implementation of the IP address management, the name of the driver, the subnet that has been associated to that, and all the containers. So as an example, default DNS as this IP address, and so on. So the vanilla container that I have created in the previous slide has got an IP address here. You can see that inspecting the bridge or inspecting the container itself. So if you connect via a shell to the running container and you issue the ifconfig for the default Ethernet, you will see the same IP address that has been registered here. So there is a couple of virtual Ethernet interfaces that are associated. So now I will use the Contiv implementation to create a new network in this environment. So netctl is the API, the client, binary client of the REST API that does the same things that can be done via the user interface or the REST API eventually integrated by the resource managers. So netctl has different commands based on nets, of course, groups, and policies. So you will issue netctl net create, netctl group create, netctl policy create, and so on, with the parameters. So I am associating this subnet and giving it a name. So if I run netls, I will see that there is one network named contivnet on this subnet, and based on a big VXLAN encapsulation. There are different options, of course. Now, if I go back to Docker and I do a network ls, I will see the new network listed together with the existing default networks. And the driver is net plugin, that means Contiv. If I inspect the network with the Docker tools, I will see, of course, the driver, net plugin, the name of the network, the subnet that I've given, and one container that has been generated, default DNS that is already associated to this network. If I want to create a new container and attach it to the network I have created, I will simply use the -- net and the name of the network. So it's easy. It's identical to what you do in a native Docker environment, because ContivNet is just one of the networks available in that environment. So I am creating a container from the Alpine distribution of Linux, and it has been created immediately. Now I create one more. I will give it a different name, Contiv C5, just to show that they are on the same network, they can communicate, and of course they don't communicate with other containers on different networks. So those are the containers available now. I have Contiv 5, Contiv C1, and they are both on the ContivNet network that I have created. So they, of course, can ping to each other, but if I try to ping the vanilla C, the first container I created on the Docker network as a first step, they don't communicate. Now, tenants. This is one of the most important features, because just creating networks across a cluster is important, but it's not the life-changing feature. Now, creating separate environments that don't see each other, that can live on a shared infrastructure that is common, so gives you the economy of scale, gives you performances, but you want to slice that in different environments dedicated to different organizations, or different projects, or different customers that don't want to have interference across them. So creating tenants is very easy. netctl tenant create and the name of the tenant. So you can create many of them to separate resources. So now I create a network, net create. The name is ContivNet, but I associated it to a tenant. So -t blue is the new network. I used the same network and the same name, but I have created a completely separate object. And by the way, this network is not communicating to the ContivNet that I have created before, because it is embedded in the blue tenant. So only users, applications, and containers that belong to the blue tenant will see this network. The others will reference with the same name a different network. So I create the network, I issue the ls command for the nets, and I see that I have a default tenant, network ContivNet, and this subnet. If I issue the net ls command with the tenant blue, I will see the same name and same subnet, but under a different tenant. So instead of default, I have blue. And they don't talk to each other. So I can move the application from one tenant to another tenant and make it live in a different world, even though I don't change any configuration in the application, just because the name is referencing a different object. So now I create more containers. So the name is Contiv Blue C1, and I attach it to the new network. As you see, I can put the blue tenant as a specification to distinguish across different namespaces. So we did a step ahead, but we have not completely solved all the requests from the ATA administrator. We want to manage the system by policies and to manage by large groups of containers. So policies are separated from tenants. They can work with tenants, within tenants, but are a way to apply a specific configuration to a group of objects. So I create policies with the same syntax, netctl policy create, and give it a name. So this is an empty box now. It's just a container for rules. And then I create the rules. So netctl policy rule add, the name of the policy, and the number of the rule. Then I can assign attributes like direction, in or out, protocol, ports, actions. So I can allow or deny specific traffic. So if I do policy rule ls with the name of the policy, I will see all the rules, that could be many, of course, that are part of this policy. So the policy is an object that contains complex configuration inside that I create just once, and then I apply to a container or a large group of containers. So the group is the key concept here, because once I have created a group, I will bring all my containers to it and manage them consistently. So I create DB group as a group associated to this network and using this policy. So the ports that I have defined open or closed in the rules part of the policy. ls, and I see the group with the network and the policies associated. So now I run a container, and for the networking aspect, I just reference the name of the group. So I create new objects, I deploy them, and I say the system, they are part of that group. So please treat them the same way you treat all the other objects in the group. So I create more containers, again with the Alpine Linux distribution, and I associate them to the group, putting that instead of the name. So now I have 3 containers in a group, and every modification I do to the policy will be applied to all of them. If they are 10,000s, they will immediately get the configuration that I've given. So this is important in the integration with resource manager that manage a large number of objects. And this is a graphical representation that probably is the best way to understand it. I create groups for specific containers or specific components in the architecture of my application. They live inside the tenant, so the big box is a tenant. Of course, I can use the same architecture in different tenants. They will not talk to each other. So all the containers in a group could be a cluster running a microservice. And they talk to each other according to the rules that I have defined in the policies. So it's very easy to manage, I would say, drag and drop business logic and data access in groups and manage them this way. And it is also an easy representation that can make application developers and system engineers talk and understand each other. Because otherwise, if they start talking about subnets and firewall rules and so on, it's difficult. I remember when I was an application developer or an enterprise architect, I didn't want to talk to the network engineers because they spoke a different language. I did not understand them. And in my opinion, it was a waste of time. I just told them I will create a cluster of 32 application servers based on WebLogic. I want they talk to each other over multicast eventually, and they should be accessible from internet to the user. That is all I want. I don't want to discuss about reverse proxy, subnets, VLANs, and so on. By the way, after 9 years at Cisco, I'm still in the same situation, so I'm still a software guy. My daughter knows networking better than I do. So using policies and groups is the key for success. And it helps you to scale and to manage without errors. So we think that Contiv is addressing all the needs for an enterprise-grade infrastructure because it answers all the questions or the needs of the operations team and make them happy because they can easily manage a very robust and performant architecture. So the value proposition is that it is production ready, it is very strong, easy to use, and it is for free. So you can go to GitHub, download it, and start using it immediately. So I copied the URL again because really I invite you to try it. It's easy. You can learn it in half a day and test it and eventually try to replicate in a real project. There is plenty of documentation, so if you want to take notes, I will keep it for a while, but of course the presentation will be distributed on the Codemotion website. And I hope I've given you a value, because as we said, everybody is talking about containers and microservices, but few people are really doing that, and few are running them in production. Now it's time to leverage the value of these technologies, and this is a solution that makes it easy. So you can use that as an individual worker on your computer, because you can create a cluster of virtual machines that talk to each other and run your containers in them, or deploy that in a large data center on a cluster of big hosts. It will work the same way. And of course, you can move the application from one environment to the other one without any reconfiguration or hard work to setting parameters. I think we are done. Are there any questions, comments? Applauses? No, thank you.
Is it also able to cope with VLAN tagging across different VLANs, or, for example, on the same VLAN but across different machines?
Absolutely, yes. So it can be the glue across different implementation of virtual networking and make them work all together. Yes?
My question is about how these will coexist with a typical approach. If you are working, for example, with Docker, you say Docker Compose, so you have your overlay networks, and you are declaring in every container which ports you open, which ports you bin all the containers to. So how we make this coexist when you have Contiv? Do you still need the overlay networks? Do you still need to declare ports in every single container?
Okay. So the CNM specification used by Docker Swarm, as an example, allow for different plugins to work together. So they can be installed all together. So you can use Contiv as just one more network in your environment, or could be the only one, of course, it's a choice. Generally, containers are associated to networks by name. So you can just switch one container from a default Docker network to a Contiv network, it will work. So there is no problems in coexisting. And of course, since Contiv is distributed over a cluster of users, eventually in a hybrid cloud environment, it can spread the networks on all the hosts you need. I don't know if that answers the question.
I mean, what you're saying is that I just simply use the Contiv driver, so I don't need to set up the regular overlay networks. I just create the others for the containers that I need to isolate and do.
Absolutely. Contiv have different working mechanisms, so it can work on L2 or L3 integration between the machines, or eventually delegating to physical networks like Cisco ACI, and it will take care of the encapsulation and the distribution of the network. Yes?
Could you share the roadmap of next features for Contiv?
No. No, actually, it's been open source because Cisco is, of course, trying to drive that into the right direction and putting our resources in the evolution, but it's open to the community. So now we are no longer the ones that decide. We will discuss that in the community.
But you have some ideas
Yes, so in addition to the networking plugin, there is also a storage plugin. But of course, there are many other very good storage plugins from NetApp or other storage vendors, so it will be a matter of choice. But it will increase and offer the user interface and the consistent management model in addition to the CLI, the command line. So probably the open source version will keep the command line and the API, but if you want a graphical interface, that will be the paid version. But I'm not sure about that.
Could you give some example of REST API for grammatically?
It will be an HTTP post or GET with the same names that you have seen in the command line. So create network or network create, and the parameters attached in a JSON format. Okay, no more questions, I think. Thank you again, and have a good day.